Welcome back for Unit 11, Lesson 5, Simplifying Radicals again. This time we're talking about rationalizing denominators. Okay, and your objective is listed there. Let's go ahead and get started. Okay, we just got quick reminders of the properties we learned, product property and quotient property. So now let's go ahead and look at the product property as if we were simplifying something like the square root of, let's say, 16a to the 5th. Okay, where we would break this apart into the square root of 16 times the square root of a to the 5th. And again, a to the 5th, we would have to break apart into an exponent that's going to have an even number. So we've got the square root of 16 times the square root of a to the 4th. Sorry, a to the 4th times the square root of a. And then we'd finish this off and say the square root of 16 is 4. The square root of a to the 4th is a squared. And then with the square root of a, we just leave, simplified. So that's the product property, breaking it apart, okay, or putting them together. And then the quotient property, again, we've got this where we split up. If we got a fraction underneath a radical, we split up into the square root of the top and the square root of the bottom. Alright, let's go on to the next slide for some more review. Again, an expression with radicals is in simplest form if you got no perfect square factors other than 1 underneath the square root symbol. So if we got something like the square root of 8a squared, again, we break it up into the square root of 8 times the square root of a squared. And square root of 8 has perfect square factors. Square root of 8 has the square root of 4 times the square root of 2, and then times the square root of a squared. And then we're going to simplify what we can simplify. Well, the square root of 4 is 2. The square root of a squared, I can simplify that. That's just a. And the square root of 2 is simplified because there's no perfect square factors underneath the radical. Alright, and again, now when we got fractions underneath the square root symbol, we've got to break it up. So we've got the square root of 3a over the square root of 4. Alright, now when you look at the top, the square root of 3a, if I break that apart, okay, into the number and the letter, neither one of them have a perfect square factor. So I just need to leave it alone. Okay, and the square root of 3a is going to stay as the square root of 3a over, and the square root of 4 is 2. Now again, I've got no fractions underneath my square root symbol, and underneath my square root I've got no perfect square factors, because 3 has no perfect square factors, and neither does a. So I'm just going to leave this as written. Okay, now I don't want to take this and split it apart and say the square root of 3 times the square root of a. Okay, I want to keep it together if neither one of them can't be broken down anymore. And then we can have no radicals appearing in the denominator of the fraction. So this example, 2 over the square root of a squared, the 2 stays, and the square root of a squared is just a. And then 2 and a can't simplify, so I'm done. Okay? And if we look at the very last example here, again, I got a radical in the denominator. Now my problem with this example is that I cannot simplify the square root of a. It has no perfect square factors. Okay? So, with what we've learned so far, there's no way we can simplify that. Okay? But again, I can't have a radical in the denominator. So we have to have a method to get rid of this. Okay? And that's where we're going to get into today's lesson, which is called rationalizing. So we're going to go ahead and look at examples like this when we've got a radical in the denominator that can't be simplified. Alright, so let's go to the next slide. Okay, before we go to the next slide, though, I just want to take a look at something. This is some knowledge that we're going to have, okay, when we rationalize the denominator. So, the square root of 4 times the square root of 4. Well, the square root of 4 is 2 times, and the square root of 4 is 2. So that equals 4. Okay, so look what happened here. If I don't do any other work here, the square root of 4 times the square root of 4 ended up just being 4. So basically, when you multiply the square root of a number times the square root of the same number, you're going to get the number that's underneath the radical here, if these two numbers are the same. Okay? So for example, the square root of 3 times the square root of 3. I can't simplify these themselves, but if I combine them, okay, then I'm going to get 3. And here's why. Okay? Well, because, remember, product rule says I can take these and combine them into one radical. So the square root of 3 times the square root of 3 is the same as the square root of 9. Okay? Which is 3. So again, if I take a radical times itself, I'm going to end up with the number that's underneath the radical to start with. Okay? And that's knowledge we're going to have when we talk about rationalizing denominators. So let's go ahead and jump into this now.